Hi, this is part 7 of debris removal by using a re-entry vehicle. We have seen earlier 6 videos. Now I have shown here this photograph sketch. Figure 1 shows the re-entry trajectory here, and then there is an RV, that's the re-entry vehicle, and DB is the debris bin, debris collection. So from the orbit, whatever is the debris coming in, it will be collected by this particular debris bin. So it will be attached to the re-entry vehicle, and then it will be coming to the re-entry trajectory. So where the debris bin will be detached, and it will be allowed to burn at around 75 to 80 kilometers altitude from Earth. So now we are going for the re-entry vehicle design. In the earlier videos we have seen the re-entry vehicle design. So we have seen one bottom mounting frame, and then you have got one the crew compartment strengthened by the internal rings. So bottom mounting frame and internal rings will be the strengthening items for the re-entry vehicle. We have shown the vehicle shape also in the previous videos. So it can be like HL20 or Dream Chaser or your own design. So only thing is, if you go for a standard design, so your aerodynamic stability tests will be saved. You don't have to go for once a year tests. If you are going for a new design, you have to go for the wind tunnel testing. You have to go for the wind tunnel testing for the aerodynamic testing, that is aerodynamic stability. Okay, so there are so many parameters you have to monitor by going for a wind tunnel. So then there is a plasma tunnel which goes for the high temperature at high altitude. What is high temperature involved? Plasma. That is called the plasma will be encountered by the vehicle. So that temperature will be simulated to the ground. So up to 1650 degrees centigrade for the orbital entry and 2800 degrees centigrade for entry from lunar missions. So we already talked about this at length. So now we will be going for the design of the vehicle, re-entry vehicle, with the standard design we will take. So with that, what will happen is we will save all the aerodynamic testing. So we will straight away go for other aspects. For example, now we will go for the previous video. I shown the wing, the wing flap. There are two flaps, one on left and right. So that will be inclined at 40 degrees from the vertical. So that is called wing flap. It has got a symmetric profile. It goes under the NACA system, NACA profile. It may be 0012 or 0009. So these two profiles are there. Road section will have a different profile, NACA system, and the free end will be having another system. So now the debris bin will be something like a conical frustum of a cone. So that will be attached to the re-entry vehicle. So when the vehicle comes back from the ISS space station or from the orbit, space station people will be dumping all the waste in the debris bin, and the debris bin will be attached to the re-entry vehicle. So it will be starting for its own journey. So re-entry vehicle will come to the from the orbit, it will be deorbiting. It will go to re-entry trajectory at around 90 kilometers. It will be entering real orbit, real atmosphere. At 120 kilometers there will be real entry, but at 90 kilometers you will have a thicker atmosphere, and when it reaches 75 kilometers to 80 kilometers, you will have a very thick atmosphere where you will encounter plasma. So the vehicle has to encounter plasma. So the plasma temperature will go up to 20,000 degrees centigrade in the free stream. But whereas when the vehicle reaches the vehicle skin temperature may be around only 1650 degrees centigrade for orbital entry missions, as depicted or as witnessed by the various real missions. Okay, from Apollo missions, the skin temperature was estimated to be 2800 degrees centigrade. So several TPS was adapted for these things. That was actually the vehicle has to have some TPS, thermal protective system. So it will have the different TPS. It will have ablative tiles, it will have simple ceramic tiles, or it will have some kind of carbon-carbon composites. Okay, so it will have some ablative systems like what I have designed here. I am going for annular passage on the re-entry vehicle, both in the crew compartment, tubular sections, as well as the surrounding, the fuselage. So fuselage body mounting frame I will be following, and that fuselage will have two layers. One will be top layer and the other one will be bottom layer. There will be an angular gap of 60 millimeters into which the ablative material will be stuck. So that will be ablating when the temperature reaching around 1650 degrees centigrade on the vehicle. So it will ablate. It will escape via the transpiration holes. There are lanced holes on the top layer. Both material will be SS. Top layer and bottom layer will be SS. Okay, it will be standing up to 1400 degrees centigrade without melting, but safety temperature will be 800 degrees only. So 2000 degrees maximum. So now this exiting gases will keep the outer layer up to say without melting up to 1400 degrees centigrade. So the ablated gases will help. And in addition to that, there will be transpiration cooling. It will be happening because of the high temperature and the reflective surface. The emissivity of the surface will be around 0.8. So that will be emitting. So whatever the heat load coming inside the vehicle, it is conducted into the vehicle, will be re-radiated by the emissivity property of the re-entry vehicle. Okay, to a certain extent, 1650 skin temperature will be withstood by the re-radiation phenomenon. The second one will be ablated gases will go to the go to the transpiration holes or the lanced holes. So thereby the melting of the metal will be prevented. And then, if in order to have the extra temperature, so for example, 1400 degrees centigrade is the melting temperature of SS, 1650 is the skin temperature, 250 degrees extra temperature will have to be withstood by the ablated gases. So that will be giving the convection cooling into the boundary layer. Okay, so that convection cooling will be the safeguard for the re-entry vehicle. Okay, so the transpiration cooling as well as the convection cooling will be the two phenomena which will be the TPS system for this re-entry vehicle. This is the end of the video. Thanks a lot for watching. Thank you.